Hello, everyone. It's my pleasure to speak with you about the 5G security revolution and its security challenges and opportunities. My name is Wendy Frank, and I'm a principal at Deloitte. I am the Cyber 5G leader, and I am also one of the leaders in our cyber IoT practice. A bit about my background to get started. I have over 25 years of experience in cybersecurity and technology consulting, including application development, data, enterprise networking, and product development, and in the past I have served as a chief security officer. As for our agenda today, we will cover an overview of 5G, we will talk about 5G deployment types and security considerations, security features of 5G, zero trust as it relates to 5G, an overview of multiple industry use cases, a deeper dive into a use case from the power and utility industry, and we will close out with some common 5G security challenges. Let's move to the next slide and get started. When people hear the term 5G, some people think about the service on their mobile phones. While that is important, of course, to most all of us, 5G is so much more than that. 5G will affect every industry. It will increase network reliability, provide faster data exchange, enable new applications, and allow for better global connectivity. This shift can be compared to the one experienced when we moved from traditional IT to cloud computing. Prior to 5G, devices connected to one base station at a time, and resources were dedicated to each connection. This provided greater control with fewer resources and allowed us to monitor traffic at dedicated choke points. However, it led to limited connectivity and slower response times. With 5G, devices are serviced by multiple locations simultaneously with the use of cloud resources. This allows for lower latency, less interference, and provides capacity for greater connectivity. With the enhanced network reliability and capacity, 5G is set to play an important role in the massive expected growth of IoT devices and related data. However, 5G shifts some of the hardware-based functionality to software, increasing the potential vulnerabilities and attack vectors. And as the number of connected devices increases, it also increases the attack surface. These are some of the examples of how the cyber landscape will change with 5G adoption. Unlike 4G, where deployment types were limited and mostly built by telcos, the nature of the software-defined 5G network enables organizations to build their own 5G networks if they choose to do so. Doing that gives them complete control of the equipment and the security. In general, all types of deployments are suitable for the various types of use cases, but here we've mapped the critical ones, which would be best used with a private network. We have three basic configuration options. First is the standalone private 5G network. This is a physically isolated and independent private 5G deployment where the organization buys 5G core and radio directly from the vendors and deploys it on-prem while either leasing spectrum or buying their own in auction. This will provide unified connectivity within restricted coverage. In technical terms, it has a dedicated private 5G core and a dedicated radio access network, and it's restricted for use by the enterprise. This allows the organization to have control over the quality of service and also to control distinct security zones. It also provides full control over data in motion as well as data at rest. Second is the hybrid 5G network. This is a private 5G network in conjunction with one or more public networks, meaning that the organization hosts parts of the 5G network on-prem while agreeing with a telco partner to connect to their core 5G functions. Telcos enable that by network slicing or by extending their network to the organization's facility by deploying a new base station in a factory or outside a hospital, for example. In technical terms, the 5G core network and the radio access network are shared. This may allow for partial control over a network slice depending on how it's deployed. It allows for full control over private data, and public data must still be shared. Third is the public 5G network. In this type, a communication service provider provides public 5G using network slices for unified connectivity within an enterprise. This option is similar to 4G's legacy network, where the telcos own the technology and negotiate data plans or subscription deals with enterprises. In technical terms, in this type, the 5G core network and the radio access network are publicly accessible. It allows for limited control over the network slice security and there is a possibility for exposure from slice to slice. And data may be exposed at both the edge and the infrastructure. 5G includes some new built-in security features, including the extensible authentication protocol, which improves integration between 5G and Wi-Fi. Control plane privacy, which allows signaling messages for access and paging to be shared without sharing the subscriber's identity. To further elaborate on this feature, 4G networks were vulnerable to privacy and security threats by the so-called IMSI catchers, which exploited 4G's ability to reveal the subscriber's identity over the air. 5G came along to patch that vulnerability by concealing the user's identity to neutralize such 5G attacks. Also, 5G includes the infrastructure security framework to identify false base stations and to help prevent data snooping and denial of service attacks. Such frameworks are still being enhanced in Release 17 and will enhance 5G network security. Security Edge Protection Proxy, also known as SEP, is used to secure connections between roaming networks and optional integrity protection of all data exchanged between users and the network. All of this gives a private 5G network control over the authentication of IoT devices. The on-site data processing reduces the risk of data interception, and it gives the enterprise IT department more control over network security. And simultaneously, more connected devices means a larger attack surface, including things like smart meters, connected vehicles, and mobile edge devices. There is increased risk in the supply chain as organizations are vulnerable to more potential points of failure, and security provisioning is generally more complicated. As 5G advances workforce mobility beyond the limits of local network perimeters, traditional perimeter defense will no longer provide adequate protection. With 5G increasing the number of devices connected to the internet, the expanded surface area raises the risk of exploitable vulnerabilities. Agile defense techniques are required to handle this increased risk of attack. Zero Trust promotes real-time monitoring and visibility, combined with proactive technologies for better anticipation of malicious activity and the ability for preemptive action. Alignment to Zero Trust reduces the risk and impact of attacks through independence of user privileges and processes, resulting in a more resilient environment. The dynamic defense technologies promoted by Zero Trust safeguards organizations regardless of where the connection originates. Zero Trust follows the principle of least privilege. It provides continual authentication and dynamic user authorization. It provides full application stack protection for workloads through microperimeters and granular policy controls. It includes data classification controls. And for devices, it includes the establishment of trust devices with strong authentication and device interrogation. It's also supported by network segmentation access controls, and it secures hybrid multi-cloud environments. 5G is expected to affect most every industry, from smart manufacturing featuring improved predictive maintenance, supply chain optimization, better tracking of assets, automated workflows, augmented reality for improved training, and also improved personal safety. We will talk about a more in-depth energy and resources example on the next slide. For retail and consumer products, 5G will enable virtual reality for reimagined customer experiences, intelligent inventory replenishment, improved supply chain management. Smart cities will include smart lighting, smart traffic control systems, and also smart parking. The automotive industry will benefit from improved remote diagnostics and new fleet management features. And the technology, media, and telecom sectors will see augmented and virtual reality for entertainment and gaming, better streaming, and also improved mobile advertising. Global investments in 5G are expected to grow at a rapid pace over the next 5+ years, which will revolutionize the way energy is delivered across the electrical grid. 5G will allow for the extreme amounts of data transfer and storage required with smart grid. Smart grid modernization is the implementation of IoT devices on a substantial scale, which allows for mass connectivity of the grid. A key topic of 5G is Internet of Things, IoT. 5G's increased data transmission rates and lower latency allows for the adoption of smart devices in all aspects of the electrical grid. 5G improves authentication and real-time management of IoT devices. The The biggest challenges of 5G and IoT are third-party risk, increased entry points, and lack of governing standards for innovative IoT solutions. The use of drones has been evolving in the utility industry, and 5G can ensure that there is a reliable connection with these devices. 5G and drones have the opportunity to decrease operations and maintenance costs, improve data quality, and enhance worker safety, among other benefits. Let's take a look at the overall 5G benefits and challenges across the energy supply chain. For the benefits, 5G will provide transmission system operators with real-time data and enhanced data availability, and it will create bidirectional grids, cutting losses and potentially lowering prices. 5G will improve the management of distribution lines and allow for remote operation and real-time visibility. 5G also offers privatized network and two-way authentication with enhanced encryption capabilities. There are challenges. The challenges of 5G include increased entry points to the electric infrastructure, the existence of old legacy devices and protocols, and the requirements for increased infrastructure. Let's review some challenges and approaches to manage risk. 5G will enable new applications in many industries. Be sure to follow secure software development processes from the start, as well as perform proper testing throughout. 5G will impact network architecture, so be sure to do proper architecture assessments and design security from the start. As IoT devices produce more data and more data is analyzed, stored, and utilized, think about personally identifiable information, personal health information, and other types of sensitive information, and ensure that special data is properly secured. For critical infrastructure, examine asset controls, endpoint and device security, identity management, and physical security controls. Create a cyber 5G operating model based on industry standards such as 3GPP and complete with risk assessments, policies, and procedures, and be sure to include privacy considerations as well. Because 5G will enable more IoT devices, network monitoring will be very important. Remember to conduct base network scans, interface assessments, authentication, identity, device management, examine virtual networking, and also software-defined network settings. The shift from hardware-based networks to networks that are software-driven and use the cloud will create new attack vectors that will require dynamic protection. Think about the proper use of encryption, tokenization solutions, threat logging, and monitoring. Thank you for joining today, and I look forward to your questions, and please join us for the panel later on.